we're going to show you how to diagnose the 60PZ550. We're going to be using a jumper and we're going to short out those two pins. That's how you trigger the color pattern test. This is the most commonly failing part of this circuit board. So we'll go ahead and start heating it up. HDMI 4 is popping up, our menus are popping up. It looks like we got a successful repair. Now let's jump into the full diagnostic. We're going to plug it in and see what it does. Let's take a look and see if we have any standby here. We do. The red light is on, so let's power it up. And I don't know if you guys saw this on camera, but there was a little bit of a flash, kind of a glow on the screen, but now there's nothing, just a black screen. What we're gonna be focusing on first is our main board. We're gonna go ahead and actually disconnect it out of circuit and see if we can get our color test pattern to show up. So in order to do that, what we're gonna do is we're actually going to be also using our logic board. There are two pins right here that we're gonna be shorting together, and at the same time, we're going to be disconnecting the power over here. And one hand is gonna be a little tricky, there we go, as well as our ribbon. So we disconnected the power and we disconnected the ribbon. Now we're going to be using a jumper and we're going to short out those two pins to one another. What we're going to do next is plug it in, and again the main board is disconnecting at the power and the LVDS ribbon. And when connected, because the main board is disconnected from power, it should actually automatically turn on. So there's going to be an auto on command when the main board is disconnected. And we're seeing a bright red, bright green, white color pattern test flashing on the screen, blue. And what that indicates is that every single board that's still in circuit, so our buffer boards, Y sustain, power supply, logic boards, Z sustain, are fully functional. The only board that is out of circuit currently is that main board. So that is a confirmation that the main board is the cause of our failure here. If we did not get the color pattern test that we're seeing on screen right now, it would indicate that the main board is okay, and one of the failed boards is one of the remaining ones that's still in circuit. So the board is able to be removed at this moment, and what I'm going to do is we're going to flip it over and remove the heatsink here. So when I flip it over, you'll notice that there's these four pins, and what we need to do is we need to just pinch the sides of it and then push those through to release the heatsink. So that's what I'm going to do next. Okay, the heatsink has been removed. The CPU is exposed. I have reconnected all of our connectors, and I have screwed the board back in since we'll be lifting it up to check the screen. So our next step is going to actually be heating up this Bga chip, and the reason we do that is because this is the most commonly failing part of this circuit board. What happens is we get cracked solder joints between the solder balls that connect the circuit board to the chip. And that is usually caused because of heating and cooling occurring from the TV turning on, warming up, and the balls expanding, and then the TV turning off, cooling down, and then the solder balls contracting. That expansion and contraction happening over and over again eventually will cause those micro fractures in those solder balls. So what we're going to do is, with this hot air gun, we're going to heat it up for about 20-25 seconds or so, and the idea is that the heat is going to cause the metal to expand and temporarily reform those broken bonds. So we'll go ahead and start heating it up. We'll go ahead and plug it back in. And we still have our standby light. Press the power. We've got our quick glow on the screen, but still no picture. Oh, wait a minute. There we go. Look at that. HDMI 4. Let's try to bring up the menu. And there it is. Okay, so I'm gonna actually disconnect the TV from power pretty quickly here because I don't have my heatsink, and I did apply a fair amount of heat to the processor, and of course we don't want to leave it on and damage it. So this is, however, a confirmation that this is our issue. So our next step is we're gonna move the board out of the TV again, and we're going to bring it to our rework station and do the actual repair of the board.
Alright, so today we're going to be working on an LG 60PZ550. It's a board that Nick handed me. It comes from the storefront, and it has your classic failure with the central CPU, the Bga. So we're going to go ahead and rework that. We're getting pretty close to reaching our desired reworking temperature for this non-leaded solder. Alright, we're now going to check the back of the board to make sure our capacitor readings are correct. Once again, this is just to make sure that you've not damaged the Bga during reworking, because you definitely do not want to be powering this thing on if you did damage the Bga. So we're getting 183. I usually expect close to 200 above 150. Yeah, and then this one's 300, so we're in the clear. Alright, we'll hand it back to Nick and he can install it on the TV and see how it goes.
We have our main board back, and I have the heatsink placed back on there. One thing I did want to also add is I am adding a thermal pad on the back of the Bga chip that we reworked. What this pad is it's an 8mm thick thermal pad that will help transfer heat away from the board, away from that processor, and it will actually move that heat into this metal sheet here. So what we're doing essentially is we're building an extra heatsink, and this whole sheet is going to become our heatsink that's going to be on the back of the board to assist with the one that's in the front. So we're going to go ahead and put everything back together, and then we'll boot it up in a second. Plug it in, and it's turning automatically on here, most likely because it was in the on state last time we disconnected it. And let's see, and there we go. HDMI 4's popping up, our menus are popping up. The last thing we'll do is just run it for a couple hours to make sure that the repair is 100% and that there is nothing else that could be going on. But it looks like we got a successful repair. So there we go. If you did find the video useful and helpful, give us a like, subscribe. If not, leave us a comment, let us know why, and I think that we can make some improvements for next time. Alright, thanks for watching.